So the exams are inching ever closer, and whilst you've been doing your revision, I've been creating a new set of questions, hopefully a tiny bit more difficult than last time for those that are really trying to get the top grades. Called this level difficulty 3 out of 5, whereas last time I was saying it was 2 out of 5. Take everything with a pinch of salt. They're not going to be the actual questions which show up on the exam, but the ideas should be very helpful. We'll go through the questions one by one. As usual, if you have any questions, put them below. Question 1 is only worth 2 marks, but hopefully it's a nice introduction to the paper. So we're giving a nice little diagram here, but there are no numbers. And this is something that I think exam papers are doing more and more often, because then you can't use the calculator as much. You can't necessarily cheat by drawing the graph yourself. We're told the information that the x-coordinate of the maximum is A and the x-coordinate of the minimum is B. Well, that's just in the diagram here, up here and down here. And the question is right in set notation and in terms of A and B, the set of values of x for which f of x is increasing. Now, increasing is what it sounds like. It's going up. And where is this function increasing? Well, it's increasing over here. It's going up, 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 up until it stops. This bit, no, that's going down. That's not increasing. But once we get past B, it's increasing again. So in order to write this, we are thinking about all the points to the left of A, which means that x is less than A, or not in the middle bit, but after B. So or x is bigger than B. And in terms of set notation, we saw this in the other video too. We do our squiggly lines, we do our x, we do our colon, and we then copy and paste x less than A, x bigger than B. Because there's two sets and they are separate, then we take the union symbol, the U, from our probability definitions. And there we go, that's our set notation for the values of x for which f of x is increasing. In question 2, we have a triangle called SAM, and SAM has coordinates 354, 544, 667. We need to find, first of all, the size of the angle SAM. So I'll quickly sketch the diagram and then we'll look at how to do it. So the angle SAM is what we're looking for. That's up here. I'll call that theta. Now this should be reminding you of either the sine rule or the cosine rule, because we've got a triangle and there's an angle that needs to be found, and we don't know it's right angled. It might be, but we don't know that. Because we've got the coordinates and we don't have the actual side lengths, that's the first thing I'm going to do. So there are two ways of doing this. You could be thinking in terms of vectors. So I'll do that for SA. So for example, we could say SA is going to be equal to the vector of A, 544, subtract the vector for S, 354, which will be 2 minus 1, 0. And then the modulus of that, the absolute value, the size of that, will be the square root of 2 squared plus 1 squared, or minus 1 squared, but you get the same answer. And that should be equal to root 5. So I'll put that up here. That's one way of finding the size of that. The other way, and I'll do this for A to M, is to say A to M, the size is going to be the big square root of the x coordinates difference, the y coordinates difference, and the z coordinates difference, all squared and added together. So 6 minus 5 squared, added onto 6 minus 4 squared, added onto 7 minus 4 squared, like this, which is 1 squared, 2 squared, and 3 squared, which is 5 plus 9, or root 14. That's two ways of doing it. There are probably more ways, but those are the two that first come to my mind. We want to also find SM, because then we've got all three sides, and then the angle can be found by using the cosine rule. So let's quickly find SM. I'll do it using the second method. And I get root 19. So I'll put that here. So the cosine rule, we've got three sides, we've got one angle, that's what tells us it's a cosine rule. The cosine rule starts by looking like Pythagoras' theorem, but then, oh no, it deviates a bit. Minus 2bc cos A. The little a and the big A, those are the two that are opposite each other in the diagram. So we know that little a in this case will be root 19. B and C, who cares? Put them whichever order you like. I'm going to make B root 5 and C root 14. And then B and C are going to be times together and then times by 2. And then cos A will be cos of theta because it's the angle in the diagram. A root squared is just the same number underneath. And then we've got 5 plus 14 in a similar manner. And then this will be minus 2 root 5 root 14 cos theta. But hey, look at this, 19 and then 5 plus 14. If we subtract those from both sides, then we'll get that 0 is equal to this expression here. Divide by that stuff, all goes away. Cos theta is equal to 0. And what does that mean? That means that theta is actually equal to 90 degrees. So it actually is a right angled triangle. Who knew? So we get 90 degrees, and that should hopefully help us for the next part of the question, because it does say, hence, find the exact area of the triangle SAM. Well, how do you find the area of a right angled triangle? Half base times height. So the area of SAM is half. What's the base? The base is going to be this one here, root 5. And the height is going to be the other one here, which is root 14. Well, you could change those around. You could alternate them. Root 19 is the hypotenuse, so you'd never have to use that one. And in total, we get half root 70 as the area of SAM. Question 3, my favourite integration. We've got the integral of 3x e to the x dx, and it's from ln2 to 2ln2. So a bit wacky, and we have to find it in a specific form that's given there, k lots of ln8 minus 1. So when you see this, you might be thinking, oh, there are so many different integration techniques. How the heck am I supposed to know which one to use? It's x times by e to the x. Two quite different functions that don't often go together. So it's a product, so we have to use the by parts method. And what we need to do is be able to assign the value of u and v dash, and then therefore find u dash and v, and then follow the formula to finish it off. In this case, u will be 3x. That's because if we wanted to differentiate 3x, we'd get to 3, and that makes it simpler. Whereas on the other side, if we wanted to integrate 3x, we'd get 3x squared over 2. That's got more complicated. That's not good. If we leave v dash as e to the x, we integrate it to e to the x. It's not got any harder, it's not got any simpler either, but there's no change. If in doubt, if it doesn't seem to work, change it round and try it again. The formula tells us that we want to do these two, uv, so that's 3x e to the x, and we want to minus the integral of the bottom two, at least the way I write it, so that's 3e to the x, not forgetting the dx. And then this will be 3x e to the x. How do you integrate e to the x? We did it over here, just stays the same. And then the 3 constant will just stay there as well, so 3e to the x. We are still doing a definite integral, so I'm going to put the limits back in. If I was doing it really rigorously, I should definitely write the limits here, but I'm being a bit lazy. And let's see what we're going to get. We're going to get 3 lots of 2 log 2 e to the 2 log 2 minus 3e to the 2 log 2. That's just for the first limit. And then we're going to minus exactly the same thing, but just 1 log 2 instead. Like this. Unfortunately, you can't put this into the calculator. It won't give you it in the form that it wants up here. So we have to do a bit more slow working out with ease with logarithms in order to see where it's heading. So let's see what we're going to get. We can at least do 3 times 2. So that's going to give us 6 ln 2. The rules about logarithms tell us that an e and a logarithm will cancel out, but there is a 2 in the way here. So what we can do is we can take this 2 and we can bring it up. So we change 2 log 2 into log 2 squared, like that. Now the e and the ln are right next to each other. Boom. 2 to the power of 2. That's just the same as 4. Let's do it the same for this one. E and ln not right next to each other. So take the 2, bring it up as a power. That's the law of logarithms. E and ln cancel out, 2 squared. So it's another times 4. We can do the same thing over here. We've got 3 ln 2, e to the power of ln 2. I mean, look at that, lovely. It's already e and ln right next to each other. No problem. Same for this one. Those cancel out. Get 3 times 2. Let's keep going. This time we've got 6 times 4. We're going to get 24 ln 2 minus 3 times 4, which is 12. Minus, that's going to be 6 ln 2. And then we're going to add on 6. Keep simplifying. We're going to get 64 minus 6 minus 12 plus 6, like this. It's beginning to look like the value of k should be 6, but let's just make sure. Bring out a factor of 6. We get 3 ln 2 minus 1. Does it look exactly the same as the answer? No. What's the problem? We need to bring up the 3, again using that same law, bring up the 3 as a power, like this, which will give us 2 to the power of 3, or 8, which is as required for nice 5 marks. So k would be 6. Question 4 is quite short, it's only 3 marks, it's only 1 line. Prove by contradiction that there are infinitely many multiples of 13. So it tells us it's a contradiction. And if it's a contradiction, that means we need to assume the opposite from the get-go. So assume for a contradiction, so we'll hopefully get a contradiction at the end, the opposite of what the statement is saying. What's the opposite of that there are infinitely many multiples of 13? Is that there are finitely many multiples of 13. So assume for a contradiction that there are finitely many multiples of 13. If there are finitely many multiples of 13, then surely at some point there is a biggest one. So we can say let n be the largest multiple of 13. Because there's a list, there's a finite list, you could put them in order and you could say, well, take the one at the very end. That's the largest one. We're going to call that n. And now what I can do is I can say, well, consider, there's actually loads of ways I can do this, but I'm going to consider n plus 13. N is a multiple of 13. 13 is a multiple of 13. So that means this whole thing is a multiple of 13. Because when you add together multiples of 13, you get a multiple of 13. You could spell this out a bit more. You could say this is 13k plus 13, like this. If you really wanted to, you could write it in words as well. But this is bigger than n. N plus 13, you're adding on 13, it's bigger than n. That's where the contradiction comes in. It's a contradiction because we said n was the largest. So therefore, n is not the largest multiple of 13, which is a contradiction. And if we've got a contradiction, then it means that the original assumption was wrong, which means that there are actually infinitely many multiples of 13. So contradiction, therefore, rewrite out the question. There are infinitely many multiples, get this right, of 13. Quite a wordy question for 3 marks, but the same idea could come up for any multiple. Question 5 then, we have got 3 points, A, B and C. They've got coordinates 1, 1, 2, 2 and -1, 2. And first part is find the gradient of the line passing through the points A and B. So that should be simple enough, hence it's only 1 mark. We're going to do y2 minus y1 over x2 minus x1. That's just simply 1 for 1 mark. For part B, we have to hence find the equation of the perpendicular bisector of A and B, which is a bit of a mouthful, but the maths is easier than saying it. So we've got 2 points, 1, 1 and 2, 2. If we know that the gradient between these two lines is 1, to find the perpendicular bisector, if it's perpendicular, then we need to think about this gradient going this way. The gradient of this line will be the negative reciprocal of 1, which is -1. To find the equation of a straight line, y minus y1 equals mx minus x1, we now have the gradient, which is great, it's -1. But we need a y1, we need an x1, we need a point on the curve. To find that, we need to find the midpoint of A and B. Well, that's just going to be the average of 1 and 2, so 1.5, or 3/2, for both coordinates x and y. We're looking for the actual equation, so I'll probably rearrange this slightly. I'll times everything by 2, like this. And I'll just expand out the brackets like this, and then I'll probably put everything onto one side like this, and why not divide by 2 now, just because it's possible. There we go, so x plus y minus 3 equals 0. Now for the interesting bit then, hence find the equation of the circle which passes through those 3 points. So I made this a bit harder. I've not said exactly what you have to do to find the circle, but I have hinted by parts A and part B. Talk about the perpendicular bisector of A and B. Well, why not find the perpendicular bisector of another 2 points? And we'll see what happens when they cross over. So this is part C. How about we find the perpendicular bisector of, let's do B and C. So the points B and C, they have coordinates 2, 2, and then -1, 2, like this. The perpendicular bisector of these two lines will look like this. And because the y coordinates are just the same, 2 and 2, it means that the line will be of the form x equals something or other. And because the x coordinates are between -1 and 2, it means the x coordinate is going to be the midpoint of that, which is a half. So we've got x is equal to a half, and we've got y plus x is equal to 3, or y plus x minus 3 is equal to 0. Well, what if we combine those two together? If we combine those two together, we're going to get y plus a half minus 3 is equal to 0, which means that y is going to be equal to 3 minus a half, or 2.5, or 5/2. Now, if you've seen this process before, that's the centre of the circle. So the centre of the circle will be 1/2 and 5/2. Wherever the two perpendicular bisectors cross, but you could find all three if you really want, but there's no need, that's where the centre of the circle is going to be. So centre of the circle, 1/2, 5/2. We're not done yet though, we're looking for the equation of the circle. That doesn't look like an equation to me. So remember the equation, x minus the coordinate of x at the centre squared plus y minus the coordinate of the centre squared, and it should be equal to r squared. How are we going to find r squared? Well, we've got x and y. We've actually got 3 candidates of x and y up here, 1, 1, 2, 2, -1, 2. We can sub any one of them in. We should get the same value of r in each case. I'm going to do 1, 1, see what we get. So sub in 1, we're going to get 1 minus a half, which is a half, squared. 1 minus 2.5, so minus 1.5 squared, or 3/2 squared. And that should be the same as r squared. If I add those together, we're going to get 1/4 plus 9/4, which is 10/4. which should be equal to r squared. So that tells us that the value of r is going to be root 10 over 2. We don't really need the radius, we want the equation, so let's write this in full. X minus a half squared plus y minus 5 over 2 squared is going to be equal to r squared, which is 10 over 4. That's our equation. Done. Question 6 is partial fractions, and because I've made it this difficulty 3 out of 5, I've given you the factors in the denominator and I've given you the form it needs to be in. So in a more difficult one, they could just say write in partial fractions and not give you any hints. But for this one, I've given you the denominators x plus 1, x plus 2, and x plus 3. Make sure you understand this process because it comes up pretty much every year. The way I like to do this is I like to times left and right by the denominator. So x plus 1, x plus 2, x plus 3. On the left-hand side, that's just going to leave us with the numerator. And on the right-hand side, in each case, there's going to be one bracket which cancels out. And that means that you're going to be left with essentially the other two brackets. So for A, the x plus 1s are going to cancel out, and you're going to be left with the other two brackets, x plus 2 and x plus 3. For B, the x plus 2 will cancel out, and you'll be left with x plus 1 and x plus 3. And then finally for C, the x plus 3 will cancel out, and you'll be left with x plus 1 and x plus 2. So it looks a bit nicer because now there's no fractions to deal with. Next up, we want to be trying to find a certain value of x for which some of these terms over here will cancel out. The easiest way to do it is choose the values of x for which the denominators here are 0. So for example, what's the value of x for which x plus 1 is 0? That would be x is equal to minus 1. And what you can do is you can just sub x's in everywhere and see what happens. So over on the left, we're going to have 6 minus 22 plus 18. And on the right, you might notice minus 1 plus 1, 0. Minus 1 plus 1, 0. So those two terms, the b and the c, they disappear completely. And we get left with minus 1 plus 2 and then minus 1 plus 3, which is going to give us 2a here. And over here, we're going to have 24 minus 22, which is just 2. And then that tells us that a is going to be equal to 1. So we find the value for which the denominator is 0, sub it in everywhere. Most of the time, lots of things will cancel out, rearrange to get the value of the letter. Next, I'm going to choose x equals minus 2 because that's when this denominator will be equal to 0. And then we substitute it in. So we're going to have 6 lots of minus 2 squares, so 24. We're going to minus 44, and then we're going to add on 18. When x is minus 2, that's going to disappear. When x is minus 2, that's going to disappear. So all we'll be left with is b. And for b, we'll have minus 2 plus 1, so minus 1. And then minus 2 plus 3, so 1. And then over on this side, we'll have 42 minus 44, which is minus 2. So minus 2 will be minus b, which means that b will be equal to 2. We repeat the process again. X is equal to minus 3 for the third denominator, and then we sub it in. So this time we've got 6 times minus 3 squared, so 6 times 9, so 54, minusing 66, and adding on 18. X equals minus 3. Look out for the x plus 3 brackets. Swoosh, swoosh, disappears. All we'll be left with is this one over here. So that's C lots of minus 3 plus 1, and then minus 3 plus 2, like this. And then over here on this side, we're going to have 6. Yes, 6, and then that should be equal to 2C, which means that C is equal to 3. That's me being really imaginative. A is 1, B is 2, C is 3. Who'd have seen it coming? So for this type of question, you maybe don't have to, but I'd probably say rewrite it in the given form just to show exactly what it should be equal to. And it might also help if there's ever a further question, you can write it out using the given form that you've just found, x plus 3, just like that. Question 7 then. A sequence has first term 2 and third term 5. We're first given that the sequence is arithmetic. So remember that means that it goes up in a linear fashion. You're adding on the same common difference each time. Using the information in the question, what I can say is that U1 is 2 and U3 is 5. That's the first term and that's the third term. But we also know that the general term, the nth term, is equal to A plus n minus 1d, where d is the common difference, A is the first term, and n is the term that you're looking for. This formula is not given in the formula book, so this is one you have to memorize. So we've got the first term, which is when n is equal to 1. So let's see what we're going to get. So u1, A plus 1 minus 1 is 0. So u1 is equal to A. Straight away, A is equal to 2. Let's do the same thing for 3. u3 is A, 3 minus 1 is 2, and that's going to be equal to 5 because it matches up here. But we know what A is. A is equal to 2. So 5 is equal to 2 plus 2d. 3 is equal to 2d. So d is equal to 3 over 2 or 1.5. What we're actually looking for in this question, I should probably actually read my own question. Find the sum of the first 25 terms of the sequence. Okay, so it's a summation. We've got a formula for this. That should be n over 2 brackets 2a plus n minus 1d. That's in the formula book, so there's no need to memorize that, but if it lodges itself in your head, why not? It also maybe gives you another way to remember this formula that I've started up here. If you know to look for just that bit there, it's a sneaky way of learning the formula without memorizing it. Anyway, we're looking for the sum of the first 25. So let's see, 25 over 2. Let's change that to 25. 2 lots of A. A is 2, so that's going to be 4. N minus 1 is 24. And then D is 3 over 2. So let's put it all together, see what we're going to get. 25 over 2, 4 plus 12 times that, 36. 25 over 2 times 40, 25 times 20, which is equal to a lovely round 500. In a shocking twist of events in part B, we're told instead that the sequence is now geometric. And if it's geometric, it doesn't make a difference to the fact that the first term is still 2 and the third term is still 5, but it does make a difference with the formula that we have to use. Now the new formula, and again I'm going to star this in a second because you aren't given this, it's A times by R to the power of n minus 1. And this time, R is the common ratio rather than the common difference. So that's the thing that you have to times by each time in the geometric sequence, rather than add each time in the arithmetic sequence. So we are still given that U1 is equal to A. So we can still use the fact that A is equal to 2. And now by considering U3, this will be A R to the power of 2, and U3 is still 5. A is still 2, so 5 is equal to 2r squared. 5 over 2 is equal to r squared. So r is going to be plus or minus root 5 over 2. If I look at the question, it doesn't tell us that r is positive or negative. So what I'll do is I'll correct that question afterwards and I'll make sure that r is going to be positive. And in part C, we need to find the sum of the first 25 terms of the sequence. This time we do get this formula given. It's the other summation, but this time for geometric, which is A 1 minus r to the n over 1 minus r. Again, like the one up here, it's in the formula book, so you don't need to memorize it, but some formulas just seem to stick in my head, whether I would like them to or not. So let's see what we're going to get. We know what A is, it's 2. 1 minus r, taking the positive value of r and raising it to the power of n, which is 25. Dividing it by 1 minus r, like this. We'll see what we get in the calculator, and then we'll round it to 3 significant figures. So we get this massive number, 3321. And if we round it to 3 significant figures, then we'll get 324,000. Wow. Question 8, this one looks fun. We are doing a coefficient of x to the power of 5 in this wacky expansion 2 minus 3x over 4 to the power of minus 1. And we have to give our answer in the form of 3 to the p over 2 to the q. How interesting. Because it's an expansion and the bracket is the power of minus 1, we probably want to use that second expansion formula in the formula book. So let me quickly get that now and we'll have a look. Here we go then, here's the formula. Again, if you memorize it, no harm done, but you do get it given. There's something different about this one compared to the formula. What's this 2 doing here? We don't want it there. So this is what differentiates this question from the one that was in the previous paper. Because there's a 2 there, what we have to do is we have to separate the 2 out with a bracket. And we're going to get 2 lots of 1 and then 2 lots of minus 3x over 8. Make sure you put an 8 here, not a 2. Make sure when you times 2 by this fraction, you get the original. Do that little check to make sure that you don't go wrong from the get-go. And then what's missing is the power of minus 1. And a common mistake here is to put the minus 1 on the end, but not put it in a bracket. The reason that matters is because this is 2 to the power of minus 1 and then times by the bracket to the power of minus 1. So now we're thinking, what's the x to the 5 coefficient here? And then whatever it is, we can just times it by half. So let's think about that. The x to the 5 coefficient, using the formula, in general, it's here. So we're going to take the power, which is we're calling n, which in this case is minus 1. Then we're going to do minus 1, so minus 2. And we're going to keep doing that, and we're going to keep doing that until we get to the power that we want. So that is here, it's x to the power of r, which in our case is 5. So in our case it's minus 1 plus 1, which cancels out, and then minus 5. But I like to think of it as just, you want x to the power of r, do r terms in total. We're going to divide that by 1 times 2 times 3, all the way to r. 1 times 2 times 3 times 4. We want 5 terms, so we'll go to 5. X is not x. I know that sounds a bit strange, but x is this whole thing. Minus 3x over 8. And then all of that thing is going to be to the power of 5. So in order to find the coefficient of x to the power of 5, we need to consider just the number terms of this expression up here. But something quite nice happens. 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. All cancels out. 2 negatives cancel each other out. These 2 negatives cancel each other out. All you're left with is minus, and then whatever this expression is. 3 to the power of 5 and 8 to the power of 5 I'm going to leave separately, because then I can discuss what the coefficient is. So I've taken out the bracket of x to the power of 5. So I can say that the coefficient of x to the power of 5 in the original expression is going to be equal to 2 to the power of minus 1 times by this number here. So minus 3 over 8 to the power of 5, which is not such a nice expression, but you got to deal with these things. 2 to the power of minus 1, that's the reciprocal of 2, is 1 over 2. I'm going to separate out these to get minus 3 to the power of 5, like that, and then 8 to the power of 5 like that. But I know that because it's minus 3 to an odd power, it's going to be the same as minus 3 to the same power. I know that sounds exactly the same, but without the brackets. The minus at the front here turns that into a positive. And then we've got that times by a half. That's not quite in the form given. So to get it in the form given, we need to turn this 8 to the power of 5 into a power of 2. So that's 2 lots of 2 to the power of 3. We've already seen that today, to the power of 5. Which we get 3 to the power of 5, and then 2 times by 2 to the power of 15, which is 3 to the power of 5 over 2, 15, add 1, we get 16. What a question. In fact, that's actually quite fun because we can write that in a different way. We could do 3 to the power of 5 over, well, 16 is 2 to the power of 4. And 4 is 2 to the power of 2. So if you really want, 3 to the power of 5 divided by 2 to the power of 2 to the power of 2 to the power of 2. So that's half the questions done, but we'll just do one more before the intermission because it ends at the end of the page. So function in this question is half times by cos of x squared plus pi over 2, which is a little bit strange. And we're told that 0 is less than x is less than 2 pi over 3. So I'm going to write that down, even though it's written right there. In part A, we have to differentiate. That's what f dash of x means. And there are different methods to do this. Essentially, we're using the chain rule, but I think if you want to be getting quick at doing this type of differentiation, remembering it as what I call a mini rule is really beneficial. So my mini rule will state that if f of x is cos of g of x, so cos of another function, then the derivative will be differentiate cos and you get minus sine. So in an ideal world, the answer would be minus sine and then just stick the g of x in. But that's not right, and it's not an ideal world. You have to times by the derivative of g because of the chain rule. If you can remember that as a mini rule, then it works for cos, it works for sine, it works for e, it works for tan, it works for lots of functions, and it just means that you can answer a 2 marker like this in the snap of a finger and thumb. Alternatively, if that doesn't work for you, go back to the U and V version of the chain rule, or whichever version you prefer. You can still get the 2 marks. In the way I'm going to do it, what I'm going to do is I'm going to say the half is a half. That's not part of the function, that's just a constant on the outside. Then this is going to be, this cos is going to change to minus sine. And the inside, I'm not going to change it, the u. What am I going to put here? I'm going to put the derivative of the inside. The derivative of this is just 2x. Neaten it up slightly, divide the 2 and the 2, you get minus x sine x squared plus pi over 2. Using that mini rule, you get to the answer nice and quickly. Then in part B, we have to find the exact coordinates of the stationary point of f of x. Interesting. So what happens when we're at a stationary point? We need the derivative to be 0. Luckily for us, we've just found the derivative. So dy dx is equal to 0. I really should say f dash of x, but that's fine. Minus x sine x squared plus pi over 2 is equal to 0. Can we divide by x? We actually can, because we know that x is not equal to 0. According to the question, x is bigger than 0, so there's no problem dividing by it. We can also divide by minus 1, because that's not helping us out here. So that means that sine of x squared plus pi over 2 is equal to 0. When is sine equal to 0? That's when the middle bit, in our case x squared plus pi over 2, is equal to 0, or, pi, or 2 pi, or etc, etc. That's from the sine diagram, which looks like this: 0, pi or 180, 2 pi or 360, and all multiples of pi thereafter. That means that if we subtract pi over 2 from all these values, we're going to get minus pi over 2, pi over 2, 3 pi over 2, dot, dot, dot. And we want to square root both of them here. Obviously, that's never going to be square rooted. So we're going to get x is equal to the square root of pi over 2, square root of 3 pi over 2, etc, etc. So I would plus or minus these solutions, but given the range, there's only one solution which fits inside, which is the square root of pi over 2. So that's going to be the only solution that we're going to take. But we're looking for the stationary point. That's not a point. Look for the stationary point. The x-coordinate is going to be square root pi over 2. What's the y-coordinate going to be? Well, let's take the x and sub it back in. See what we're going to get. 1/2 cos that thing squared is just pi over 2 plus pi over 2. That's going to give us half cos pi. Cos of pi is minus 1. So the coordinate of the stationary point will be root pi over 2 and minus 1/2. So we're about 50 marks in, halfway there. Let's have a little break and we'll get back to question 10 in a moment. Okay, let's move on to question 10. Question 10 is such a beast that I'm going to have to extend the screen. We've got 3 parts here, A, B and C, and we're given a diagram. In the diagram we can see that it consists of a sector, OAB, and then a triangle, AOC. We're told that the circle has radius r, and we're told that the ratio CO-OB is 3:2. And finally, the angle is theta. In part A, we have to show that the area of the whole shape is equal to that expression there. Let's see what we can do. So I'm first going to use the fact that the ratio of cube is 3:2. So the ratio of this line to this line is 3:2. If I just call that x for now, x to r is 3:2. That tells us that 2x is equal to 3r if we cross multiply them, which tells us that x is equal to 3/2r. So straight away I'm going to put that in terms of r because I don't see any other letters other than r and theta in the answer. So I'm going to try and get everything in terms of r if possible. So we want to find the area. What's the area of a sector? Well, given it's in terms of radians, I'm going to use the formula half r squared theta. You can use the formula in terms of degrees, but to be honest, the radians one is nicer. We're going to get half. R squared in this case is literally r squared, and theta is also literally theta. So half r squared theta is the area of this here. If the radius was different, you'd change the radius. If the angle was given, you'd change the angle there. What we're going to add to that, we're going to add the area of the triangle. The area of a triangle is half AB sine C. And in this case, A and B are these two lines here, OA and OC. So half R 3/2R. And C is going to be whatever this angle is in here. Let's call it phi. Again, looking at the answer, there's only r's and thetas. So we're going to have to be able to find what phi is. Luckily for us, it's on a straight line. So CO and B are on a straight line. Therefore, phi is going to be equal to 180 or pi, minus theta. So that means that the total area is going to be half r squared theta. If we simplify this, we get 3/4 r squared sine of pi minus theta. It almost looks like what we're trying to get here. Like I see a quarter, I see lots of r squareds, I see a few thetas about, but the sine of theta doesn't look quite the same. So for this one, you have to realize that this is a compound angle, sine of something minus something else. We're going to put that into the formula and we're going to see what it is the equivalent to. Here's the identity then at the bottom of the page there if you didn't know it already. And the formula tells us if we want to find sine of A minus B, or in our case pi minus theta, then we do sine of A, which is pi, cos of theta, and then we subtract, do it the opposite way around. So sine of theta, cos of pi. Or the formula says cos, and then sine doesn't really matter. Sine of pi is 0. And what we're left with is minus sine theta times cos of pi. We saw cos of pi before, that was minus 1. And then minus 1 times minus 1, that's 1. This is the same as sine theta. So let's go back to the formula up here. Half r squared theta plus 3/4 r squared. That whole thing is just sine theta still. So I'm just going to write sine theta. And now it's just a case of putting it in the right form. In the question given, it wants a quarter on the outside. So I'm going to put a quarter on the outside first and then the r squared. If we've got a quarter r squared, then there's a theta in there. And then we need to add in a 2 to make it 2/4, which is a half. And then over here, we've got 3 sine theta. And then that matches up with the answer that's given. So as required. What do we want to do with this information then? We're now given that r is equal to 1. Lovely. So what I'm going to do first is I'm literally just going to rewrite the area as 1/4 2 theta plus c 3 sine theta. I don't know if I'll even use that, even though I wrote the question. Just because the r is now given, if we have to use this, then it might be nice to be in terms of numbers and not r's anymore. We're trying to find an expression for CA in terms of theta only. So that is this one up here. We could potentially call that y. If we call that y, and we know what r is now, it's equal to 1. And we know what r is, it's equal to 1. What rule does that make you think of? It makes me think of the cosine rule. So the cosine rule tells us that, again, it's the two that are opposite, which are the first and the last thing. Y squared is going to be equal to b squared plus c squared. Doesn't really matter which way around it is. Minus 2bc cos of the angle. The angle is not phi because we want it in terms of theta. The angle is pi minus theta. So that means that y squared is going to be equal to 1 plus 9 over 4 minus 3. And then cos of pi minus theta, we don't know. Let's work it out. If I scroll down, then we can see that the formula here for cos of pi minus theta is cos of pi cos of theta plus sine of pi sine of theta. In this case, just be careful that you have to do minus plus because it's upside down. So I've got to plus here because there's a minus here. Sine of pi is still 0. Cos of pi is still minus 1. So cos of pi minus theta is the same as minus cos of theta. So if I add this on here, this is going to be now plus 3 cos of theta. And then that gives us the final answer. So an expression for CA, if I call this CA, it's going to be the square root. If I add these two together, I'm going to get 13 over 4. 13 over 4 plus 3 cos theta. And to finish off, turns out we didn't need that area formula, but that's fine. Hence, show the perimeter of the composite shape can be written in that form. The perimeter is going to be all of the side lengths added together. So the perimeter, let's start from C and work our way around anti-clockwise. It's going to be 3 over 2. Then we're going to add the radius, which is just 1. Then we're going to add the arc length BA. So remember the arc length formula is just r theta. So in this case, 1 times by theta, which is just theta. And then we're going to add y, and we know what y is, it's this expression here. Square root 13 over 4 plus 3 cos theta. 3 over 2 plus 1 is 5 over 2, like that. And I realised in the show that looks like that should be a 5, so I'll correct that before I send out the PDF. So we get the perimeter is equal to 5 over 2 plus theta, and then this we need to sort out a bit. That's times the inside by 4, 12 cos theta plus 13 over all over 4, which means we can write it as 5 over 2 plus theta plus take out 1 over 2, square root of 4. And then finally, if you just about got enough room, take out a factor of a half from everything. So theta times by 2 cancels out, plus 5 plus the square root of 13 plus 12 cos theta to finish off. As I say, that should be a 5. I'll correct that in the original document. Right, question 11 is a curve defined by parametric equations. X is 1 plus t over 1 minus t. And y is 2t squared minus 1 over 2t plus 1. We're also given that t is bigger than minus a half, which feels like it could come in handy. In part A, we need to find dx dt and dy dt. To differentiate, we need to realise that this is a fraction. So there's no other call for it other than the quotient rule. The quotient rule tells us that if we want to differentiate f over g, then we need to use this formula down here. And in order to do that, we need to differentiate the numerator, which will be the derivative of 1 plus t, which is just 1. And then leave g of x, leave the denominator the same. we then minus the opposite of that. So leave the numerator the same and times by g dash, which is the derivative of the denominator, which is minus 1. And then divide that by g of x squared, which is the denominator, squared, like this. Let's quickly simplify that up. We've got 1 times 1, and then 1 times minus t, and then we're minusing minus 1 minus t. And to finish it off, 1 plus 1, which is 2, and then minus t plus t, which is nothing. So the simplest version of dx dt is 2 over 1 minus t squared. Let's do the same thing for dy dt. So we use the formula in the same way. So we're going to get 2. If I do it in the same order, we'll get 4t, because that's f dash, times by 2t plus 1, which is g of x, minus, and then I'm going to write f, which is 2t squared minus 1, times by the derivative of 2t plus 1, which is 2. All a bit of a mouthful. We divide by g of x squared, 2t plus 1 squared. If you do it in a slightly different order, like I was about to do, it doesn't make a difference. It should give you the same answer in the end, however you remember it. Let's times it out. We're going to get 8t squared plus 4t minus 4t squared, and then that's going to be plus 2 because of the two negatives, divided by the same denominator, and then just to simplify even more, we're going to get 4t squared plus 4t plus 2. For the next part, it says hence find a simplified expression for dy dx. So you've got to understand that to get dy dx, you need dx dt and you need dy dt. We're going to do dy dt divided by dx dt. I know that doesn't look very nice. That's the only way we're going to find it, dividing one derivative by the other, because the dt's cancel each other out and give you dy dx, which is what we want. So if you don't want quadruple fractions, then you can of course write it as dy dt divided by dx dt instead, and you can go back to your rules of fractions and do a keep flip change that to times 1 minus t squared over 2. If we do that, we get a simplified expression. These all have a factor of 2, so I'm going to just divide them all by 2. 2t squared plus 2t plus 1. 1 minus t squared, all divided by 2t plus 1 squared. That's our simplified expression for dy dx. In the last part of this one then, we want to find a Cartesian equation of c. So that means try and get rid of all the t's. Doesn't look too nice, but let's see how we're going to work it out. We want to get t on its own first, and then substitute it into the other equation. I think I'm going to go for x here. And the reason is there's no squareds, there's no funky business really going on. To get t on its own, I need to definitely times by 1 minus t. Otherwise, how am I going to get rid of that fraction? If I times by 1 minus t, then that gives us an idea. Oh, we're looking for t. So let's get all the t's on one side, and let's get everything else on the other side. So I've minus 1 from both sides and added tx onto both sides as well. I can now realise where I'm going to go with this, because if I want t, then I'm going to multiply t by 1 plus x in a bracket. And then with a little bit of division, t is equal to x minus 1 over 1 plus x. Now when I was making this question, I came up with a few different answers here, and it looks like I've changed the question since I made this answer. So if you're just watching this video and you've not tried the question yourself, currently this answer is wrong, and the show that is going to be different. If you've looked at the question paper yourself, then the answer should be correct. I've also changed the sign up here to less than minus a half, because otherwise something goes a bit wrong. Anyway, let's continue through the maths. We'll see what the show that answer should be, and then it should be changed by the time you're looking at the PDF. We've got t. T is equal to x minus 1 over 1 plus x, and we're going to substitute that into y. We know that y is equal to 2t squared minus 1 over 2t plus 1, which is the same as 2 lots of t squared, which we just found, divided by 2 lots of t, which we've just found, plus 1 like this. That's not that pretty. But what we can do is we can multiply everything, every single term by 1 plus x squared. Here, the 1 plus x squared is going to disappear because it's in the denominator. Here, we're going to get 1 plus x squared. Here, the 1 plus x squared is going to become 1 plus x because one of the brackets is going to cancel and one of them is going to remain. Finally, here, 1 plus x squared is going to turn into 1 times 1 plus x squared. I'll go over here for a bit more room. So if we expand, then we're going to get 2 lots of x squared minus 2x plus 1 minus 1 plus 2x plus x squared divided by 2 x squared minus 1, plus 1 plus 2x plus x squared, which is going to be 2x squared minus x squared, which is going to be x squared minus 2x minus 4x minus 2x minus 6x plus 2 minus 1 plus 1, and that's going to be divided by 2x squared plus x squared, which is 3x squared plus 2x, and then minus 2 plus 1, so minus 1. So actually it's so very similar to the actual question. I think that's just because the original thing I did was the reciprocal of this, so maybe the answer is just really similar. Anyway, that should be the show that we want. And that should be corrected by the time you watch this. We're not quite done there though, because we don't have a and b. We don't have the domain. So we previously found that t is equal to x minus 1 over 1 plus x. And in the original question, we're told that this should be less than minus 1/2, or once it's been corrected, less than minus 1/2. In order to solve something like this, we need to multiply both hand sides by this denominator squared. So if we times by that denominator squared, on the left hand side we're going to get 1 bracket cancelling and then 1 left over. And on the right hand side we'll get 1 plus x squared. The reason why you have to times by squared is because you do not want to accidentally change the sign of the inequality. So if you times by positive, nothing changes. Let's see what we can do now. We can expand this. That will be x squared minus 1. And then over here we'll get minus 1/2 lots of 1 plus 2x plus x squared. I'm going to times both sides by 2, like this. And then I'm going to expand out this bracket here to get minus 1 minus 2x minus x squared. Finally, I'm going to add x squared onto both sides, add 2x onto both sides, and then add 1 onto both sides, and that should be less than 0, like this. Finally, I'm going to put that into brackets and get 3x. It's going to be plus 1 here and minus 1 here. So x will be a third and x will be minus 1. And if you remember the process, draw the little diagram if you need to. We've got roots of 1/3 and minus 1. And it's a quadratic. It's less than 0. So it's connected together. That means that the domain is going to be minus 1 is less than x is less than a third. So a will be equal to minus 1, b will be equal to a third. The original way I did this question, a and b, did turn out to be integers. In this case, b is actually a fraction, but that's okay. As I say, it should be corrected by now anyway. And after question 11 is of course question 12. In this one, we need to show that if this is true, what's given, then we can show that cot x is equal to root p, or cot x is equal to 1 over root p. We're given that root 3 cosec squared x is equal to 4 cot x. So if you know your identities, cosec squared and cot squared have an identity. If you don't know your identities, then you could come up with it yourself. Remember that sine squared x plus cos squared x is equal to 1. How are we going to get cosec? We're going to divide by sine squared. Sine squared divided by sine squared is 1. Cos squared divided by sine squared is cot squared. And then 1 divided by sine squared is cosec squared. So if you don't know your identities, it's worth being able to come up with them because then you can compare it back to the original. Because over here, the idea is we're somehow going to get a hidden quadratic. Why don't we put cosec squared in as the definition? So root 3 lots of 1 plus cot squared, like this, and we're going to get equals 4 cot x, like this. That means that root 3 cot squared x minus 4 cot x plus root 3 is going to be equal to 0. And then if we go even further, maybe we divide by root 3 cot squared x minus 4 over root 3 cot x plus 1 will be equal to 0. Now I wrote the question, so reverse engineering this is always a bit easier than solving it forward. If this were a question, they'd want you to use a bit of detail, maybe setting up the quadratic formula, maybe completing the square, maybe another method, but not just subbing this in the calculator and seeing what you get. Because if you did that, you might lose a method mark, you might lose an accuracy mark potentially. How about I do it using the quadratic formula? So cot of x minus b is going to be this thing here, plus or minus square root of b squared minus 4, a and c are just 1, divided by 2 lots of a, which is just 2. I'm going to put that 2 on the outside just to make it a bit nicer, and it's going to be 4 over root 3 plus or minus the square root of, let's square 4 to get 16, square root 3 to get 3. That's going to be minus 4, like that. And then if I do half times by 4 over root 3 plus or minus 16 minus, it's going to be minus 12 over 3, which is going to be the same as, nope, 1/2 4 over root 3 plus or minus, that's going to be root 4 over root 3. But we know that root 4 is just 2, so that's going to be 2 over root 3 plus or minus, that's going to be 2, which is plus or minus 1 over root 3. So 2 plus or minus 1 over root 3. So what do we get as our final answer? Cot of x is either going to be 3 over root 3, or cot of x is going to be 1 over root 3. Not quite how the question words it though, because it says cot of x is root p, so we just have to realise that this is the same as root 3. So cot of x is root 3 or 1 over root 3. As I say, you could complete the square, you could put it into brackets if you recognise the answers, you could maybe force the brackets, but you probably wouldn't be able to just put it in the calculator and get the answer without losing a few marks. Quick pen change. And back to it. So for part B, we are told to hence solve the equation, and it looks pretty much the same as above, but now x is being called 2 theta plus 30 degrees, and we're given this strange range 180 to 540. Don't know who chose that. We have to solve. So in order to solve, we first of all need to know how to solve cot of x is equal to root 3. I don't know about you, but my calculator doesn't have a cot function. So in order to solve cot of x is equal to root 3, we're going to have to know how to turn it into tan. But luckily for us, it's just the reciprocal. Cot and tan are reciprocals of each other. So therefore, if you want to solve cot equals root 3, you just solve tan equals 1 over root 3. The solutions for when tan of x is equal to 1 over root 3 is going to be 30 degrees. And then for tan, it's the really nice one. You just keep adding on 180 degrees. But how many times do we need to add it on? Well, this is where the range comes in handy. Sorry, that should be theta. That should be theta. So if 180 and 540 are the values for theta, then that means that 2 theta, we need to stretch the range by 2, like this. and then we need to add on 30 to both sides. So 1110, and we get 390 over here. So all our solutions must be between these two values. So we keep adding 180 until we start getting outside of that range. We get all these values, and let's just cross off all the ones that we won't be needing, including this and this, because this is a strict inequality, so it won't be included. So in this case, we get 1, 2, 3 solutions. Let's do the same thing when cot of x is equal to 1 over root 3. When cot of x is 1 over root 3, then tan of x must be the reciprocal of that, which is root 3. Therefore, x will be equal to 60 degrees, and in the same way, we can keep adding 180 to our heart's content, or at least until we run out of room. And in the same way, some of these solutions just won't be valid. In this case, we get 1, 2, 3, 4 solutions which lie within the range. So how are we going to finish off the question? Well, these are the values of x, not theta. So that means that 2 theta plus 30 is equal to 570, 750, 930, 420, 600, 780, and 960. So for all the solutions, we can now subtract 30 to get 540, 720, 900, 390, 570, 750, and 930. Finally, the values of theta will be, just put it down here, if we divide everything by 2, we will get 270, 360, 450, 195, 285, 375, and 465 as our 1, 2, 3, 4, 5, 6, 7 solutions. Wow. Probably worth checking that they're all in the range, and I see that they're all between 180 and 540, so there we go. Okay, only a few more to go on. Question 13 now. Hopefully we can finish them before it gets dark. We are given a curve y equals 1 over x plus e to the 2x, and we're given another curve 3x plus 2. We're told that they intersect at a point called alpha. Well, if they intersect, then they must be equal to each other. So the first thing I'm going to do is I'm going to set them equal to each other like this. In this question, we need to use the Newton-Raphson iterative formula, and that's going to help us find the value of alpha in that given form. Well, if I get the formula book back up again, then the Newton-Raphson iteration for solving f of x is equal to 0 is given there. This isn't equal to 0 though. So what we're going to do, let's subtract 3x from both sides and subtract 2 from both sides to get it equal to 0. This is now called f of x in our formula. The formula tells us that we need f of x and we need f dash of x. So what we're going to do, of course, we're going to differentiate it. How do you differentiate 1 over x? That will be minus x to the minus 2, because you turn it into x to the power of minus 1, bring down the power in the usual way. You differentiate e to the 2x by bringing down the 2. And then we know that minus 3x differentiates to minus 3, minus 2x differentiates to 0. Even if you forget the Newton-Raphson method completely, find the derivative because it's in the formula. It will get you maybe 1 mark, maybe 2 marks, depending on the difficulty of the question. So the formula tells us we're going to do xn minus f of xn divided by f dash xn. So that's going to be xn minus, all this is f of x, so it's going to be 1 over xn plus e to the 2xn minus 3xn and minus 2. And then the denominator, we're going to copy this and we're going to put it with xn instead of x. So minus xn to the minus 2 plus 2e to the 2xn minus 3, like this. Looking at the formula, you might notice that this is quite similar. In fact, exactly the same as the denominator over here. The only difference is that we've got two terms. They've just got one fraction in the question. So let's do a bit of algebraic fractions to get this all together. So the definition, this is all xn plus 1. I should have written that here. Xn plus 1 is going to equal xn. Let's multiply by the denominator like this. And then put it also over here. Now that's the same as xn because these two cancel out. But the nice thing is that now we can write this as a common fraction. A lot of writing today. And to put it all together, let's times this out. So xn times minus xn to the minus 2 is going to be minus xn to the minus 1. Then we're going to add on 2xn e to the 2xn, and we're going to minus 3xn. Then we're going to minus all of this. So I'm going to times one at a time and just keep track of the signs. So it's going to be minus xn to the minus 1, minus e to the 2xn, plus 3xn, plus 2, all divided by the same denominator. I'm just going to copy and paste. And then finally, this should give us what's given in the question. 3xn and minus 3xn cancel out. So we'll be left with two of these. So minus 2xn to the minus 1. One of these terms here. And then minus e to the 2xn, and then plus 2. Again, all over the same denominator. Let's look back at the question just to see if that matches up. So 2 minus 2 of those, plus 2 of those, minus 1 of those. So it's not quite in the exact form, but my hand hurts, so I'm not going to write another step. For part B, we get to use the formula now. We want to apply the Newton-Raphson method. x0, we're told, is equal to minus 1, and we're told to do it 3 times. So once, twice, 3 times. And essentially, we just put it into the calculator and hope for the best. So if we sub in minus 1 and press equals, that will save it as our answer. And then all we need to do is rewrite this whole thing. So minus 2 answer to the minus 1, plus 2 answer e to the 2 answer, minus e to the 2 answer, plus 2. Now for the denominator, minus answer to the minus 2, plus 2e to the 2 answer, minus 3. Don't know who ever said maths was hard. Press equals, and that should give us our approximation for x1, which will be minus 0.963, equals again, we get x2, minus 0.963, equals again, we get x3, minus 0.963975064. What do we want it to do in the question? 4 significant figures. So 1, 2, and then this one will be 40 because you can't round up 39 other than to get to 40. And that should be the value of x3 for 2 marks there. In question 14, we need to rewrite 12 cos theta plus 5 sine theta in the form r cos theta minus alpha. We're told that r should be a whole number, and we're told that alpha is in radians, and alpha is rounded to 3 significant figures. If I get the formula back up here, then you'll see that it's the same formula as before, but now theta and alpha, they're both unknown. Whereas last time it was in terms of pi, we know what pi is. So in this case, I'm going to write r, and I'm going to write down the formula. Cos theta cos alpha. And then if I put this in a bracket, it'll be plus, because again, it's the opposite sign, and it will be sine theta sine alpha. And I just rewrite this just to compare. If I times out the brackets, then it'll be r lots of the first thing and r lots of the second thing. So I'm just going to put an r there and then scribble away the brackets. For this type of question, you need to know how to compare. You are comparing the coefficient of cos theta on the left and the coefficient of cos theta on the right. So what is times by cos theta on the left? Just 12. What is times by cos theta on the right? It's a bit out of order, but it's r cos alpha. Almost. Let's compare the same thing for sine. What's times by sine on the left? Just 5. What's times by sine on the right? There's r and there's a sine alpha. Do you notice how I've written sine above cos? Because you know what's coming next. We're going to divide it and we're going to get tan of alpha is equal to 5 over 12. And if tan of alpha is equal to 5 over 12, then alpha will be 0.395. Or at least 0.395 when rounded. What's the value of r? To find r, we want to do the square root of the first number squared plus the second number squared. There is reasoning behind that based on the sine squared plus cos squared formula. You get marked for just doing this, so I think I'd just remember it is the formula rather than going through the whole process. In this case, we're going to get 13. I know that as a Pythagorean triple, if you type it in the calculator, you get the same thing. So part B, we are told to hence write down the maximum value of 1 plus 12 cos 2x plus 5 sine 2x. It's only worth 1 mark, so there can't be too much difficulty in this. This thing looks suspiciously like this thing to me. It has r, which we know is 13. It has cos. Theta is not theta anymore, but it's 2x. And alpha is not going to change, 0.395. What's the maximum value of this thing? What's the maximum value of cos? It's an equally equivalent question. Remember the cos graph, it goes up to 1 maximum and then down to -1 minimum. So the maximum value of this is going to be 1. So the maximum value of all of this is going to be 1 plus 13 times 1, which is 14. So there's not much working, hence why it's just worth the 1 mark. For part C, it's actually a tiny bit more tricky. If we rewrite it in the brackets, we've got 12 cos 2x plus 5 sine 2x, and then we're going to square it. Let's rewrite it in terms of this. So it's going to be 13 cos, instead of theta, 2x, and then minus 0.395. But here, there's a bit of an intricacy. Cos goes down to -1, sure, but when you square it, you get back up to 1. So actually, the minimum value is going to be when cos is equal to 0, because when you square 0, you get 0. So it's a bit of a trick question, but the minimum value when you square cos, when you square sine, is actually going to be 0. Just putting a tricky question in there for you die-hard math fans. Right, 2 questions to go. The end is in sight. We are on question 15, and it's a modulus graph. 2x minus 1 in the modulus minus k. And of course I'm going to use k, because then you can't sketch it on the calculator. In this question, we're first asked to write down, in terms of k, of course, the coordinates of the vertex of f of x. So that's this point here at the bottom. The vertex is going to come when this modulus sign is equal to 0. So in this case, when is that modulus bit equal to 0? It's when x is going to be equal to 1/2. So add 1 to both sides, divide by 2. X is equal to 1/2. If x is equal to 1/2, then that modulus bit is 0. And then what does that mean that f of 1/2 is? F of 1/2 is going to be 0 minus k, or minus k. So the vertex, I call it v, is going to be 1/2 and then minus k. For part B, the range of f of x. I know not many students like questions about range or domains, but you've got to get used to it. It is only 1 mark though, so it's not too much if you do lose it. The range is going to be, how tall is the graph? Where does the graph start? In terms of k, it starts at minus k, because that's the lowest point possible. And it can go higher and higher and higher. There's no stopping point. So in fact, the range will be just f of x is bigger than or equal to minus k. And that's it. That's why it's only worth 1 mark here, because there's not exactly much writing to do. Once you've got the lowest point, it's just anything higher. And I know the diagram does stop here. That doesn't make a difference. That goes on forever and ever. So part C, before we get on to the last question, we're given that x equals minus 0.8 is a solution to f of x equals 3 over 2x plus 1. So that means that f of minus 0.8 is going to be equal to 3 over 2 times by minus 0.8 plus 1. So they're going to be equal because it's a solution. And we want to use this to find the value of k. Let's find f of minus 0.8 then. So that's going to be 2 lots of minus 0.8 minus 1 in modulus minus k. And it should be equal to this hand side, which is half that times by 3 minus 1.2 plus 1. In here, we've got minus 1.6 minus 1, which is minus 2.6. And then if we add that, we get minus 0.2. But this is the modulus. So the modulus of a negative is a positive, like this. And then what can we do to both sides? We can add 0.2. And we can add k. So we get k is equal to 2.8. Last question then, let's see if we can just fit it in here. Find the set of values of x for which e to the x minus 4 is bigger than 5e to the minus x. If you don't recognize this, it's worth getting this association in. It's going to be a hidden quadratic in some way. Personally, I look at the e to the minus x and I don't like the look of it. So what I would be doing is I would be turning it into a fraction 1 over e to the x. Because here it's more readily seen that if you want to get rid of the fraction, you times everything by e to the x. Let's do it. Times everything by e to the x. Nothing's going to change with the inequality here because e to the x is positive. So that's all fine. That's minus 5 from both sides, like this, and that's going to be bigger than 0. Can you see now that it looks a bit more like a hidden quadratic? So make your substitution, or put it into brackets, or do your usual method for hidden quadratics. I'm going to put it into brackets, so e to the x, it's going to be minus 5 and plus 1. Now here's a bit of a strange one. We've got 2 brackets, times together bigger than 0. We usually do the method with the quadratic, but what's interesting about this bracket is always bigger than 0, because e to the x is always bigger than 0. So what that tells us, this implies that the bracket e to the x minus 5 alone is always bigger than 0. You almost can forget about this bracket, you don't need it. If e to the x minus 5 is bigger than 0, then e to the x is bigger than 5. We take logs of both sides, then that means that once we simplify that down, x is bigger than log 5. And if we find the actual set, so it says set, so it's implying certain notation, then we can say the set of values is x with the colon, such that x is bigger than log of 5. What a way to end the paper. Well, there you have it, another practice paper complete. How did you find that one compared to the last one? Hopefully it was a little bit harder, and hopefully a little bit easier than the next one. Stay tuned.